Hello student, in this lecture I will discuss about initial slope of Bode plot. So let's start our discussion. The corner frequencies due to first order terms like 1 plus j omega t1, 1 plus j omega t2, like 1 by 1 plus j omega t suffix a, 1 by 1 plus j omega t suffix b, etc. are given by omega equal to 1 by t1 or 1 by t2, like 1 by ta or 1 by tb. That means if we have first order terms like 1 plus j omega t1, then the corner frequency is 1 omega equal to 1 by t1. If we have first order term like 1 plus j omega t2, then our corner frequency omega equal to 1 by t2. If we have first order term like 1 by 1 plus j omega ta, then our corner frequency omega equal to 1 by ta, like this. Okay, so for the frequencies lower than the lowest corner frequency, the contribution towards the gain, that means magnitude in decibel, of the transfer function is nil. Therefore, the sinusoidal transfer function for frequencies lower than the lowest corner frequency can be expressed as gj omega into hj omega. This is equivalent to k divided by j omega to the power n. Okay. So, the magnitude of this expression in decibel can be expressed as 20 log 10 mod of gj omega into hj omega, and this is equal to 20 log 10 mod of k divided by j omega to the power n. Okay, so this equation, we can write this equation by this manner also. 20 log 10 k minus 20 into n into log 10 omega. So as per this equation, the graph of magnitude in decibel versus log 10 base omega has initial slope of minus 20 into n dB per decade. Okay, as n denotes the type of the transfer function, therefore the initial slope of Bode plot is decided by the type of a system. Okay, so now come to first type. This is type 0 system, that means where n equal to 0. So for a type 0 system, the equation for the initial part of the Bode plot is 20 log 10 mod of gj omega hj omega. This is equal to 20 log 10 k divided by j omega to the power 0, because here n equal to 0. So from this equation we calculate our magnitude 20 log 10 mod of gj omega hj omega equal to 20 log 10 k. Okay, and the graph of this equation, that means the 7.61 equation, is this. Okay, so for type 0 system, the initial slope of Bode plot is like this for type 0 system. Okay, now come to the type 1 system. Type 1 system means where n equal to 1. So for a type 1 system, equation for the initial part of the Bode plot is 20 log 10 mod of gj omega hj omega, and this is equal to 20 log 10 mod of k divided by j omega to the power 1. 20 log 10 k, so this equation, we can write this equation by this way also, where 20 log 10 mod of k divided by j omega, this is equal to 20 log 10 k minus 20 log 10 omega. Okay, and the graph for this equation has a slope of minus 20 dB per decade, and its intersection with 0 dB axis is given by equating right hand side of this equation, that means 7.6 to equation to 0. So if we put the right hand side of equation 7.6 to equal to 0, then we calculate omega equal to k. So hence the graph intersect 0 dB axis at omega equal to k. Okay, so the graph for equation 7.62 is this. Okay, now come to type 2 system where n equal to 2. So for a type 2 system, the equation for the initial part of the Bode plot is 20 log 10 mod of g j omega h j omega, and this is equal to 20 log 10 mod of k divided by j omega whole square, and this is equal to 20 log 10 k minus 20 log 10 omega square, and this is equivalent to 20 log 10 k minus 40 log 10 omega. Okay, and the graph for the equation 7.63 has a slope of minus 40 dB per decade, and its intersection with 0 dB axis is given by equating right hand side of equation 7.63 to 0. Okay, so if we substitute the right hand side of equation 7.63 equal to 0, then we find omega equal to root under k. Okay, so the graph intersect the 0 dB axis at omega equal to root under k. Okay, so the graph for 7.63 equation is this. Okay, so here see for type 0 system the initial slope is this. Okay, for type 2 system the initial slopes is initial slope have minus 20 dB per decade, and for type 2 system the initial slope is minus 40 dB per decade. Okay, now see, in the case of zeros of open loop transfer function GSHS located at the origin of S-plane, like GSHS equal to k into s to the power n into st1 plus 1 into st2 plus 1 like this, then this divided by st suffix a plus 1 into st suffix b plus 1 like this. Okay, so here n equal to the number of zeros of GSHS located at the origin of S-plane. Okay, so for the frequencies lower than the lowest corner frequency, the sinusoidal form of open loop transfer function takes the form as g j omega into h j omega equal to k j omega to the power n. Okay, so it can be shown that the initial slope of Bode plot is plus 20 into n dB per decade intersecting 0 dB axis at omega equal to 1 divided by k to the power 1 by n. Okay, let me clear how initial slope of Bode plot depend on the type 0 of system. Type 0, type 1, type 2 means type of the system. So initial slope depend on the type of the system. Initial slope of Bode plot depend on the type of the system. Okay.